nation's capital. We all like to talk about the weather. Meteorologists use computers to figure out the weather forecast. Let's see how it's done. Tell me, how do you start putting together a weather forecast?
I start my day by looking at the whole puzzle of the weather forecast from a very large perspective, and then I start to work my way in. And it all starts from looking at satellite imagery to what the radar is doing, current conditions, and then I get into the computer models, which really help me to break down all that material.
So how much math goes into, say, the short-term forecast? What's going to happen in the next few hours?
Everything from the beginning of my forecast to the end of my forecast is based on mathematical equations. I'm using polynomials, algebraic equations, I use calculus.
And the result of all that number crunching? An accurate weather forecast.
Well, the forecast today, we're looking off to the west because those showers are...
That's another reason math matters.
We can actually add polynomials together by simply taking two polynomials and combining the like terms. Let's take a look at an example. Let's take this polynomial, 8x squared minus 2x plus 3, and add it to the polynomial 9x minus 5. Well, what would we get? Well, we're going to now combine like terms. We're going to actually use the associative property to remember that these parentheses can be dropped, and I can add them sort of any way I want, and I can move the terms around by the commutative property. So I see no square terms except for the 8x squared, so that takes care of that term, and I check them off. But I see I've got a negative 2x here and a 9x here, so they combine to give me a plus 7x. And then I've got the number 3 minus 5, which gives me a negative 2. So there is the sum of those two polynomials, just combining like terms. Let's try another example together. Here I've got 3 polynomials I want to add. And again, the secret is to use the associative property and the commutative property to sort of rearrange things so I can combine like terms. Here I see an ab squared. Here I see ab squareds. And that's it. So I'm going to combine those like terms. Together I see one of them and two of them. I see a total of 3 ab squareds. And then what about the a's? I see 3 a's here, another 3 here, that's 6 a's, and 2 more here, that's 8 a's. So I see I have 8 a's. And I've got, well, no other terms. I've taken care of that one, that one, that one, that one, and that one, except for the constant terms. So I have a negative 2 plus 4 produces a plus 2. And so the sum of these 3 polynomials turns out to be 3ab squared plus 8a plus 2. No problem. There's another way of actually subtracting polynomials. We're still going to add the opposite, but we can do it vertically. Just like when we did with addition. Of course, we have to make sure always that the columns are all like terms. So suppose I want to take this polynomial and then subtract this polynomial. Well, what I could do is I could view the question vertically, like this, and now add the opposite. So if we were to do that, what I would see here is the following. X cubed plus 3x plus 1, and now I'm going to add the opposite, so I change the signs. Negative 5x cubed, I'm putting it in the x cubed column, minus 2x, I'm putting that in the x column, and the constant minus 4. Notice this is the opposite of this expression inside the parentheses. And now I'm going to add. Now when I add, I'm going to get the actual answers I want. So I have x cubed minus 5x cubed. That's a total of negative 4x cubes. Here I see 3 x's, and I'm subtracting 2 x's, so I still have 1 x left over, or just x. And then 1 minus 4 is negative 3. And so this difference turns out to be negative 4x cubed plus x minus 3. That is the difference between these two polynomials. So putting them in a vertical form is often quite nice because then we can see the like terms sort of all together. How about this one? This polynomial minus that polynomial. Again, I'm going to think of it in terms of columns. Now, just cutting it and putting it like that is cute and nice, but not quite correct, because you notice like terms aren't lined up here. So I've got to be really, really careful here. What are the like terms? Well, there are no terms that are like x squared, y squared, but I do have some xy terms, and I do have some x terms. So we've got to be a little bit careful. Handle with care. 3x squared y squared plus xy minus 5x. And now what I have to do is I want to add the opposite of this. So I've got to now switch all the signs. This becomes, the opposite of this is going to be negative 6x. But I'm going to write it under in the x column. So I write negative 6x. And then I have a negative 4xy. So that combines here, negative 4xy. And then I have a plus, remember I'm adding the opposite, plus 5. That's constant term, so I'll just stick that on at the very end right here. You see how I rearranged this polynomial using the commutative property? So that the terms line up in the appropriate columns. Now I can add, because I'm adding the opposite, and there's no term here to add, so I just see 3x squared y squared. And here I see xy minus 4xy, so that's a total of negative 3xy's. And here I have negative 5x minus 6x, so that's minus 11x. And then I have a plus 5. So this red polynomial actually is the difference between these two polynomials. And we got it via vertically subtracting, in fact, really, vertically adding the opposite. Let's take a look at an application where we can actually see the subtracting of polynomials actually occur in big business. And it really does. Seriously. Check it out. Suppose the cost in dollars of producing X model kits is given by the polynomial 500,000 plus 2x, and the revenue generated from sales is given by the polynomial 30x minus 0.00005x squared. The question is, find a polynomial expression for the profit from making and selling X model kits, and evaluate the expression when x equals 300,000. What is going on here? Well, we've got a company. They're producing model kits. Great. They're going to sell X of them. And it turns out if you sell X of them, well, there's going to be a cost in producing X of them, and then they're going to get some kind of revenue for selling X of them. And it turns out that those two functions are polynomial functions, and it turns out that the revenue function, the amount they get in, is given by this polynomial, and the cost is given by this polynomial. Now the question is, what's the profit? Well, the definition of profit is the money you have left over from your revenue after you paid out all your cost. So basically, profit equals revenue minus cost. You see where I'm going here? This sounds like a subtraction question. It sure is. I'm going to take this polynomial, and I actually want to subtract from the revenue, I want to subtract the cost. So now we're going to do a subtraction question. What do? I'm going to add the opposite. So if I set this up, what I see here is the following. I see 30x minus 0.00005x squared. And I'm going to now add the opposite. So I'm going to now look at the opposite of this polynomial, which is negative 500,000 minus 2x. And now I'm going to try to combine like terms. I'm actually going to try to add these things. I see 30x minus 2x, so that's 28x. I see no other x squareds here, so I just keep that term there. And then I see no other constants, so I write like this. So there is the profit polynomial, favorite polynomial amongst business people.
Yes, sir.
Now the question is, what is the profit that is generated if they sold 300,000 kits? That's asking us to evaluate this when x equals 300,000. That means wherever I see an x, I'm going to plug in 300,000. So what do we see? Well, what we see is, and this is money, so we use green. 28 times 300,000 minus 0.00005 times 300,000 squared minus 500,000. And that represents the amount of dollars that is the profit. What is that? Well, you put that on a computer or a calculator, and what you see is that this is going to be equal to $3,400,000. And what does that do? That generates a big smile for the owners of the company. This is a good thing. So notice how we were able to actually model the profit function by looking at the difference of two polynomials, the revenue polynomial minus the cost polynomial. And then we can actually evaluate the polynomial, let the variable actually equal a particular amount, number sold, and we can actually see exactly what that profit is. And with $3.4 million, I think you see the value of subtracting.